गुड मॉर्निंग स्टूडेंट्स। आज हम लोग शुरू करने वाले हैं इलेक्ट्रोकेमिकल सेल। इलेक्ट्रोकेमिकल सेल इज बेसिकली द केमिक डिवाइस इज यूज्ड टू कन्वर्ट chemical energy into electrical energy. It is a spontaneous redox reaction. In spontaneous redox reaction is basically the reaction in which oxidation and reduction goes on simultaneously. And in this spontaneous redox reaction, the delta G is negative, as you all know in thermodynamics. For example, certain electrochemical cells are as follows: zinc copper cell, nickel silver cell, chromium lead cell. The most common cell is the Daniel cell, which has EMF 1.1 volt at NTP. NTP means normal temperature pressure. The temperature normal as room temperature means 25 degrees Celsius, and the normal pressure is 1 atm. And now we can talk about Daniel cell, which is an example of voltaic cell or electrochemical cell. Voltaic cell or Daniel cell has two containers. We can say it in half cell. In left half cell, we can put two electrodes, or I think we can take one electrode only. It is the electrode made from zinc, and we can take the solution of same metal such as zinc sulfate. And on another half cell, we can take a copper rod and the same solution, copper sulfate. We can connect it from a wire with an ammeter connected in between them, and now we can pass the current through it. So when the current flows through it from zinc, it will ionize to Zn2 plus ions and SO4 2 minus ions. From here, the electrons from here the Zn2 plus ions release in the solution and SO4 2 minus ions, and the electrons are attached to this electrode and will flow through this wire and goes to another cell. And when it goes through this another cell, the copper 2 plus ion will attract toward it and attach with it, whereas the SO4 2 minus ion will remain in the solution. Now, as you see here, I have written the solution become positively charged solution, okay, and this become negatively charged solution, okay. Now zinc get zinc can oxidize to zinc 2 plus to ion into the rod. This electrons from where it take into the rod, this goes into the rod, it known as oxidation. So we can also tell this cell as oxidation half cell or left half cell, negative half cell, yeah, anode. According to the short form, you can learn it as low arm cell, left oxidation anode, negative cell, okay. And from the left half, copper get reduced to copper 2 plus get reduced from copper, it get oxygen from where, from the rod, it is not reduction also this can note this. Now the basic problem is that in the left half cell, the positive charge in solution prevents the outward flow of electron. What it means that here this positive charge, so it does not allow this electron to move around this. So it can capture it want to capture, but it doesn't happen. I can say why. And in the negative charge solution cannot accept the electrons which are coming from there. So electrons are moved here and there, here and there, here and there, okay. And okay, now can move toward this. For solving this problem, we can introduce a term named salt bridge. It is similarly an inverted U-tube glass. We can pour it into electrolyte which is inert. Inert means it cannot react. For example, KCl, K2SO4, KNO3, NH4Cl in agar powder, okay, in agar powder. What is an agar powder? It is similarly a powder which can prevent the sorry, nothing. It is semi sorry. Now, what is the function of salt bridge? It maintains the electric electrical neutrality of half cell. Basically, when I can tell you, when we get both KCl, K plus ion will go to cathode. Sorry, it will go to this positively charged reduction half cell, and sulfate will make sulfate, and the sulfate will make bond with it and it will satisfy, whereas Cl minus ion will make bond with Zn and it also satisfies, so it can electrical neutral. Now the second is it completes the circuit by allowing the flow of electron. Okay. And the third is it minimizes the liquid junction potential. Okay, minimizing liquid junction potential is what? See, if it is negative cathode, it is negative, which means anode. It is positive, which means cathode. So electric field is from positive to negative. Okay, now if it is liquid, okay, now it here is positive, here is negative, so here also become electric field which goes from positive to negative direction. Electric field is here, it is junction electric field. There is also a potential. If I can put a salt bridge here, it can neutralize the circuit, so the potential will also minimize. Okay, that's this. Now what is condition of electrolytes? Condition of electrolyte also very important. So inert, it will be inert. What is the mean inert? That it does not react with any ions or rod of half cell. Okay, means KCl is K plus plus Cl minus. Okay, now Zn2 plus 2Cl minus gives Zn Cl2, which is soluble. Okay, it get vigorously solubility. ZnCl2 will give this. Ag's electrode, we cannot, in Ag electrode we cannot use KCl NH4Cl, because if you use Ag plus KCl, then KCl have Cl minus ion which can react with Ag to form AgCl, which get precipitate PPT. So it is a problem. Now ionic mobility will good. The electrolyte which we use have good ionic mobility and equal mobility of cation and anion, and cation and anion have both equal mobility. Now both half cells neutralizes simultaneously. Due to this, both half cells will neutralize simultaneously. Now cell representation. What is cell representation? Basic formula is this, that oxidation is on left and reduction is on right. M to Mn plus, oxidation number increase, Mn say to M reduce, oxidation reduction. Was a cell reaction, zinc to zinc 2 plus 2I minus, Cu2 plus 2E minus gives Cu. Oxidation reduction, 2E minus 2E minus cut. This is the overall reaction. This is cell representation. Any doubt? Now one question, write this cell equation. I can, so can you not check the answer? Write the cell equation of this question. Very good. You can pause the video and do yourself this question. Okay, I can now see. Basically, this question, it has nickel 2 plus 2E minus. This it get 2 electrons for complete oxidation. Similarly, but here Ag plus give a electron to this, so we can multiply two below side and we get this. We can cancel the 2 minus and go to overall reaction. And now it is your basically homework. Okay, now we can plated